Hello guys, my name is Sandip, and in this session we are going to start a new chapter which deals with the magnet. Okay, so I know that everybody have seen the magnet somewhere. A magnet could be of any shape. Here in the diagram, in this picture, I can see some magnets which has the circular disc type shape, right? Small circular shape, right? Okay, so these are the magnets with the different types, right? Then now just consider one example here. Consider your mother is sewing some clothes with say some very small needle, right? Right. And consider if that needle falls on the ground, falls on the ground, right? And your mother wants you to find that needle. Okay. So how you can do that? It's very difficult because it is a very small needle, and in our home there are a lot of things, right? The needle could go behind the table, below the table, we can say below the bed, behind the cupboard, anywhere. It could be anywhere. How to find it, right? Now, just say that you have one small magnet like this, right? This magnet or bar magnet, we can say. You have that bar magnet, so right. So think on that. How you can find that needle using this magnet, right? So what you can do, simple thing, take a one big stick, right? Tie that magnet to that end of the stick, we can say, and just move that stick everywhere on the floor, as well as below the bed, below the table, where you think the needle could be. Right? What will happen? That needle will get stick to that magnet. Okay, so this is the one of the daily life example we can say of the magnet, and this is usefulness we can say, right? So these magnets are actually used in many terms you can say, right? So sometimes we have the magnet which holds the door also, right? So there are many properties of the magnets also. So what is the origin of this magnet? Where this magnet actually found? Right. So there was one very famous story of one shepherd, right? Shepherd, which who has the name of a name Magnus, we can say, right? So that Magnus shepherd has a stick. Now you know that shepherd people, right? They have some stick with them, and that stick, Magnus has that stick, and at the end of that end of the stick, it was a iron material was there. Iron was wrapped, we can say, for the stick, on the stick, right? So he was just sitting, and on you can say usual days, something like normal similar days. And what has happened in that case? One day, that stick was very heavy to lift up. He was not able to lift up that stick, right? He saw that it wasn't stuck on the stone, in the stone, we can say, but it was just in contact with the stone, but it was very heavy. He cannot lift that stick, right? Then he checked that stone very carefully, and he observed that that stick with the iron material wrapped around that stick, we can say, at the end of the stick, is actually in contact with that stone, right? Which has some properties. In contact means we can say that stick is actually sticking to that stone, we can say. Okay. So there is some attraction he observed. That is very strange, right? Normally we do not find any stick is in contact with the stone and just sticking there. It is not easily getting out of the stone, right? But you observe that, right? So that stone actually had some properties, and those properties are magnetic properties, right? So there we actually find this story goes very long ago, and then scientists did some research on that stone, and that stone is actually called as lodestone also. Lodestone means actually it has property to attract some materials like iron. Okay, so this is the magnets story, we can say. Okay, so now let's start with our chapter, and let's see what we are going to do in this chapter. Okay. Okay, so we are going to cover these topics, right? What is the magnetic effect? We already have seen the very small story, and we also know the use of that magnet, right? To find a needle, you will be able to find a needle next time. So what is the magnetic effect? When properties of magnetic fields, right? Everything is related to magnetic, right? Or magnetic fields means what? We know the normal term, normal word field, right? Field means we can consider take any example, that crop field, right? So where we actually grow up the crops, right? Similar to that, we can say what is magnetic field. Wherever there is a magnetic effect, we can say will be the magnetic field, right? We'll also see some properties of that. There is another point, magnetic field due to current carrying wire. Right now, consider if there is we know the current is flowing through all the conductors, right? We have seen that in the electricity chapter, right? So if the current is flowing through the conductors, that conductor or that current, we can say, also creates some magnetic field there. So can I say using the electricity, we can create the magnet? That's very right. Right. So it has a very huge applications in our daily life, you can say, right? So using this current, electricity, we can create the electromagnets. Those are very, very big magnets, right? There is, so if you do some research on this topic, that there is a train in Japan, I guess, right? The train is called as a maglev train. Maglev train is completely based on this magnetism application, we can say, right? What they do actually, the maglev train, we know our normal trains, right? In normal trains, there are some rails like this, right? And these are the iron rails, and train obviously has some wheels on both the sides, right? Like this. And train is going to move on this part, okay? So this is our normal train, you can see. Okay. In the maglev train, what is the process? If this is the rails type material, it's not actually the rail. Train is going to move, or we can say, if this is the train, consider, let me take another color. Yes. So they found out something train like this, and train doesn't have wheels, but it is going to float, we can say, float a little bit, not a big amount, but a little bit on this rails because of the magnetic repulsion, we can say. There is a repulsion between these rails type material, we can say, and a train, right? It is completely based on the magnetic repulsion. So obviously what will happen, as there is no wheels, there is no friction, right? If there is no friction, there will be less energy required. So this is the application of the magnetic field, which we can generate through the current carrying coil. Then there are some materials which are called as electromagnets, right? So when we say about the electromagnets, when the electricity is passed, obviously we can create the magnet, huge magnet we can create, which are useful in many applications, right? Just for example, just lift one car. If you want to lift the car, right, what you can do, create a very big magnet using this current carrying wire, and then you can lift the car. Simple, right? Then next topic we want to cover is a suspended bar magnet. Bar magnet we already know, right? What is bar magnet? Bar magnet is this type of magnet with N and north and south pole, right? What are the north and south pole? North, we can say it represents the north direction, south represent the south direction, obviously. What is the meaning of suspended bar magnet? Suspended means what? Let's hang this magnet, right? Let's punish this magnet. Hang, right? What will happen? This is called as suspended bar magnet, right? Now, what happens if you suspend the bar magnet? We are going to see that part. And similarly, according to that also, we can see how the compass works. Compass means, I'm not talking about the compass which we have in our school, which we do carry in our school, which contains the pen, pencil, etc. No, not that. Compass means the small instrument which is used to denote the directions, right? Like that. And next we are also going to see some north and south pole of the magnet and how they works. What is the magnetic field generated because of all of them, etc., etc. Okay, so let's start our chapter. So first of all, what is the magnetic effect? Magnetic effect means it is the ability of magnet to attract the we can say object that contains some iron material, right? And so I have given the example of the needle, small needle, how to find that. Use the magnet, and magnet is going to attract that needle, capture that needle, right? So this magnetic effect property or ability, we can say, we are going to use that property to find our needle. Okay, so obviously, can magnet attract every object? Can it attract the paper? Can it attract the cloth? No, it's not possible, right? So definition says the magnetic effect, you can see, it is the ability to attract objects that contain some iron, right? So magnet can attract iron, we can say, right? Or the objects that have some iron, right? Or properties like iron, we can say. Right? So magnet is going to attract those part. So whatever objects which are get attracted by the magnet, we are going to call those as magnetic object. Magnetic objects. Again, we can say, for example, iron, right? And the others which magnet do not attract, we are going to call those as non-magnetic materials or non-magnetic objects. Can you tell me the example for non-magnetic objects which magnet could not attract? Can I say it is plastic? Yes, magnet could not attract plastic. What about paper, wood, right? So all these are the materials which magnet cannot attract. Let's call them as non-magnetic materials, right? Okay, then let's see, there are different types of magnets. You can see bar magnet is a very common magnet, right? Then one another magnet is called as a horseshoe magnet, right? Now remember, every magnet should have two poles. Poles means north pole and south pole, right? So here you can see for the bar magnet, if you look closely, right, you can maximize your screen if you want to. This is written as en over here, and you can see the yes is written over here. So en represents the north pole and yes represents the south pole, right? Similarly, some magnets could be of this type, called as horseshoe magnet. Now remember, this point is very important, right? In exam they are going to ask you that what are the different types of magnet, right? You should also be able to draw some diagram for that, right? Remember that. So this is the second type, horseshoe magnet. Again, you can see north pole, south pole is also there, right? Third type is rod magnet, or rod magnet also. There will be north and south pole, right? Then ring magnet is there. It's some kind of ring with the hole inside, right? Then we have the disc magnet. At the start, we saw some magnets, right? Those are actually small circular magnets, which are called as disc magnets. So very simple differentiation between ring and disc. We can see for the ring magnet, there is a small hole in between, and for disc magnet, it is solid, completely solid. We can say there is no hole, right? And last type is wand magnet, right? Wand means what? It is just like a rod, we can say, right? Wand means you can take the example of Harry Potter, right? Harry Potter has some wand and he uses to do the magic thingies, right? So that is kind of wand. So there are these different types of magnets, we can say. Again, remember very carefully: bar magnet, horseshoe magnet, rod, ring, disc, and wand. Okay. So in exam, we have to write this different types of magnets, we can say. Okay. Now let's see the properties of magnetic field. So here, what I can see, so which type is that? Can anybody guess that? Yes, that is the horseshoe magnet, right? So for this horseshoe magnet, we want to find some, we want to write, or any magnet, we can say, not horseshoe only, but any magnet. There are properties for the magnetic field, right? Even if you could consider the our normal bar magnet also, right? So here, this is a magnet, and the things you can see here are, we can say, those are iron fillings. Iron fillings means very small particles of those iron material which could be attracted towards the magnet, right? So obviously you can see for the north and south pole, there are a lot of iron fillings are attracted by these two poles, right? And as you go away from the magnet, right, it will be less and less and less, right? Also, you can see some direction type also, right? There is some also direction for this magnetic field, we can say. Okay, so like this, can I mark something like this? This one, this one, this one, right? So there is some also direction on which that iron fillings are getting gathered, we can say, right? Similarly, here also you can see outside, right? These are directions, something like this. So what I can say, for this magnetic field, there are some directions, very simple. Okay, so obviously it is going like this, like this, like this, going away, and when we are going moving closer to north and south direction, magnetic field will increase there, right? So this is a simple thing we can say. Okay, then we can also talk about the properties of magnets, right? So these are the properties of the magnetic field, that they have some directions. We can say the strength of the magnet is closer to the poles of the magnet, right? So iron fillings will get attracted like this. So we can also do one small example, one small activity here. Right? What you can do, take any bar magnet, horseshoe magnet, anything. Right? Go outside, and wherever there is a sand, we can say, right, on the ground there is a lot of sand. Just put that magnet in that sand. If there are some iron fillings, iron particles in your sand, right, then what is going to happen, that iron fillings is going to get attached to the magnet. Now everywhere in let's say in different places there are different amount of iron fillings or iron content, we can say, in our ground, right? So you can take that magnet to different places and find out how much iron content is there, that will get attached to our magnet, right? Okay, so this is the one thing you can do. Then now, as I said, let's talk about the properties of magnet. So these are the different directions we can see for the magnet. So for the magnets, what I can say, consider the first property, that poles of the magnet. Poles of magnet. We already discussed about this one, that magnet have north pole and south pole, right? There are two poles for the magnet. Then you can say directional magnet. Or direction of magnet, let's say. So we already talked about the magnetic field. Magnetic field means what? I'll repeat again, that there is some effect of the magnet in some direction, right? In this diagram also we can see some directions in which the iron fillings are getting attracted towards the magnet. So there is a magnetic field. So magnet also has a direction, or we can say it shows north and south direction. North and south direction, right? Okay. Third property, we can say like poles repel each other and unlike poles attract each other, right? So what is the meaning of that? There's no like poles. Like poles means what, and unlike poles means what? Now consider, let's take two small toy cars like this. Okay, so these are small two toy cars. I'm not talking about the actual car. Take the small toy cars like this, right? Attach magnet here, bar magnet. Let's attach one bar magnet on this toy car. So consider this is one magnet. Let's say north pole and south pole, like this, right? We know that bar magnet has north pole as well as south pole. Similarly, attach one more magnet here. Let's say this is north pole and this is south pole, right? what you can observe in this case is if this two car keeps together with the magnets on their top, right, you will observe that these car are going to go away from each other, right? Why they are going away from each other? Because they have the north and north sides of the magnet towards each other, right? Now let's repeat the example, this activity. Let's take these two cars, and now what I'm going to do, this is our one car, one toy car. Again, I will repeat, I'm not talking about the actual cars. Let's take the two small cars like this. And let's keep the magnet again. This magnet N, yes, as it is. The second magnet, now we are going to reverse this magnet. So let's put south pole here and north pole here. Right? Now in this case, what you are going to observe is these two magnets are coming closer to each other. Means, can I say for the first case, let's divide this one. This, let's call this as the repulsion. Repulsion means, as we have written in the property, like poles repels each other and unlike poles attract each other. So this is, we can say this is the attraction. Okay. So unlike pole means what? North pole of one magnet and the south pole of the second magnet. You can say those are the repulsion, attraction, right? Like this. So these are some properties of the magnet, we can say. Let's, before moving forward, let me point out two more properties. Let me write it here. Okay, so fourth property of the magnet is magnet or magnetic poles, we can say. Magnetic poles exists in pair. Now, what is the meaning? For every magnet, whether it could be a bar, horseshoe, disc magnet, ring magnet, or wand or rod magnet, right? Everywhere, the one property is very common, that both have the north pole as well as south pole, right? So for the bar magnet, we have already seen that north and south poles are there. Even horseshoe magnet, there are north and south poles. Rod magnet will also have some. They haven't shown it here, but let's consider these are the north and south pole. Ring also, for the ring and disc, what we can say, one face, let's say top of this disc is the north pole, and the bottom side of the disc magnet is going to be south pole, like that. Similarly, wind magnet, there are two, obviously there are two opposite ends. So one will be north, one will be south. So magnetic poles exist in pair. So simple meaning, you cannot get the, I can write, you cannot find monopoles. Monopoles means what? A single pole. You cannot find a north pole or south pole. Wherever you are going to find the magnet, just like our shepherd, that is named Magnus, right? When he found a stone, that stone also has the north and south magnet. That stone, we can call it as a uh, natural magnet, right? So it is naturally found on our earth, and these are actually the artificial magnet. We actually prepare, manufacture these types of magnet. But doesn't matter, whichever is the magnet, it will have the two poles. It could be there will be a south pole as well as there will be a north pole, right? But you could never find a monopole, right? That is north pole separately or south pole separately, right? Even many scientists are studying on that, researching on that to find the north pole separate, right? But it is still, till now, it is not, it hasn't been possible to find the two different poles or single poles, we can say, right? So simple property here, we can say that north and south pole are in pair, they exist in pair. Okay, then last property of this magnets are multiply number of, we can say multiple number of magnets. Multiplying, let's say multiplying property number of magnets. What is the meaning of that? Let's discuss. Now I can see the bar magnet on the screen, right? Let me draw the one bar magnet here. South pole and north pole. And so in the previous property, we have said that we cannot find the south and north pole, right? Separately, they will be together always. So let's try one thing. Let's cut this bar magnet. There is south and north pole, right? What will happen if I cut? Can I get the south and north pole separately? Yes, I can see there, right? No, that is very wrong. Right? Remember what is going to happen if you cut this magnet. Obviously, you will get the two pieces like this for this magnet. I know this is south, I know this is north. Now, are those monopoles? No, in the previous property we said we cannot find the monopoles. So what will happen if you cut this magnet? Remember, this new north pole will get generated here. Similarly, new south pole is going to get generated here, right? So this is the property of the magnet. If you cut this magnet, again new, we can say new north and south pole are going to develop, but you are not going to get south pole separately, north pole separately. Let's cut this magnet again, right? What will happen? I can get, right, I can get this as the, again, small magnet. Again, I will get the 4 different magnets, right? South pole will be here, and this will be north. North will again generate here. Then I have the north already here. South will generate here. South, north, north, and this one is south. Okay, so if you cut the magnet, you are not going to get monopole. You are going to get, again, we can say dipole, or 2 different poles, and one pole is going to generate. One is already there, one will get generate. Okay, so we can say these are the different properties of magnets and magnetic fields. Okay, next, our next point is magnetic field due to current carrying wire. As we discussed right earlier, that if there is a current flowing through, even in our house there is a current flowing through different wires, right? If the current is flowing through it, then we can say magnetic field will be generated, right? So if the magnetic field is generated, means current carrying coil is going to act as a magnet, right? Can I say that all the current conductors are acting as a magnet? No, actually, that magnetic field is not that much, right? Negligible, we can say. If you want to act, if you want to make it act as a magnet, then obviously there are properties. Then how much current will be there, etc., etc. We need all those things, right? So, but here we can consider current carrying wire. Now, you know these electrical components, right? So consider this is our battery. Battery is denoted by what? Positive as well as negative. The bigger one is the positive terminal, and the smaller one is a negative terminal. Current is going to flow like this. Key is connected here, right? So obviously, if the current is flowing through this, what is going to happen? We are going to get some magnetic field in this section. Okay, like this. Okay, here magnetic field will be generated. Now consider the, if you reverse the battery means what? Connect the positive terminal now on this side and negative terminal on this side. Why there are a lot of positive negative terminals? Right? Remember, normally when we say one cell is connected like this, we can represent it by like this. If you connect another cell, let's say in series, so if I connect 2 cells, I will get something like this. Why we connect the more than one cell? To get the EMF, large EMF, right? Large voltage, large power, large energy, we can say, right? So this is the effect of the current carrying coil. And as we discussed earlier also, that what is the uses of that maglev train we talked about, right? The magnetic field is created by what? Obviously, we cannot put the very big natural magnet there or bar magnet, right? For train, we have to create a very big path of the magnetic field, right? Therefore, we can use the current carrying wire there, and it is going to create some magnetic field, right? Also, for the electromagnets, I talked about, right? For the when we want to lift the car, we took the example of that electric car. We want to lift the car. What we are going to do? We are going to create some electromagnets there as well, right? How? Just pass the current through the current carrying coil, and we'll get some electromagnet. Obviously, there is a lot of process. Actually, it's not that easy to get the electromagnet. We will need the iron material for that, and that iron is going to act as an electromagnet for some time, right? right? Then, now let's talk about the direction of this magnet, right? In the previous case, we have seen, right here, we have seen that there are some direction in this ion fillings are getting attracted, right? Like this. If you remember, we talked about this one. This like this. This is also going to come like this from north to south. So in general, what I can say, the magnetic field will have some direction on which these ion fillings are getting attracted, right? So simple thing is that uh, the magnetic field is from north pole to south pole. So let's talk about all this magnet. So consider this is the north pole, right? I can show the field lines like this. These are called as a field or field lines of the magnetic field. It looks something like this, right? It starts from the north side and going into the south side. Okay, so remember this part. Similarly, here also we have seen that it starts from the north and goes on to the south pole like this. So we have seen this ion filling thingy, right? So it will look something like, say a similar thing will happen for this. We can say it will be like this from north to south. South is where? South is at the bottom of this disk magnet, right? Therefore, we can show the magnetic field like this. Okay. So magnetic field have direction, that much we know, right? From north to south. North is going to attract south and south is going to attract north. And accordingly, if you keep the magnet, bar magnet, ion fillings are going to create that path, right? Like this, right? Ion fillings are going to arrange themselves in what? This magnetic lines path. Okay. Similarly, now we are not considering magnet. What we are saying, there is a current carrying coil or current carrying wire, we can say, and because of that wire, how will be the field? That's what we want to find out. So what we can do, there is one rule which is called as the right hand thumb rule. Right hand thumb rule. Now what this rule suggests, consider a straight current carrying wire like this, right? So, and let's say current's direction is upward. Obviously, how to get that direction, what we can do, we can just connect the some sail here like this, right? So, let's connect it in the reverse fashion. Positive is here, so current will go upward, right? We know the current flows from positive terminal to negative terminal. So this will be our battery. Let me remove the battery, right? We can just consider now there is one conductor which is carrying current. For this conductor, magnetic field will be generated. So how the magnetic field will generate? For that, we are going to use the right hand thumb rule. Right hand thumb rule means what? Obviously, right hand, we consider the right hand and thumb, right? So what we are going to do, imagine this conductor. We have to imagine that we are now holding this conductor in our right hand, right? That, right? Now consider this pen is our conductor. Current is going. So I'm going to use this right hand. Just what I'm going to do, this is thumb. Thumb is going to represent the current's direction like this. Curl fingers, this curl fingers, curl these fingers, and this curl fingers are going to show me the direction of the magnetic field. Okay, very simple to understand. And this right hand thumb rule is very important. We are going to use this rule many times in physics, right? Remember, right? So what I can see, these curl fingers are going from outside to inside like this. Okay. Okay, so this is how it's the direction of the magnetic field. So in this diagram, I can show something like this. Dotted lines means behind the conductor, right? Very easy to understand. And this line is in front of the conductor. So fingers are curled like this. So for this straight conductor, their curl fingers are coming from behind, and from front they are going again behind the conductor, we can say, right? So can I say that direction they are coming from the behind like this, from front they are passing, and this will be the, this will we can say is our direction of the magnetic field. So if you place the ion fillings like that, then they will get arranged around this loop, we can say. Okay, So this is how we can find out the direction of the magnetic field. And magnetic field is produced by whom? Magnetic field is produced by our current carrying wire. Okay. Then let's take another example here. If this is the coil is like this, right? And now in this coil, current is flowing like this. Okay. So what I can do, I want to find the direction of magnetic field. Now we are going to use the same rule, right hand thumb rule, but we are just going to use some notations, right? Let's replace some notations. In the initial case, what I say, that the current is going to represent the direction of the, thumb is going to represent the direction of the current. Same, right? Now consider the curl fingers are going to represent the direction of the current, because current is flowing in the circular fashion like this. So I can say if the direction of the current is represented by the curl fingers like this, right? Fingers are getting curl in the circular fashion. Then thumb represents the direction of the, we can say, magnetic field. So magnetic field will be like this. If this is our conductor, then upward will be the direction of the magnetic field. Now let's consider the case in which the, let's say this is coil and current is going like this. So if the current is going like this, again we have to use what? Right hand thumb rule. So now curl the fingers in the opposite direction like this. So what is the direction of the thumb? Outside, right? Or we can say down, right? So magnetic field will look something like this. Okay. Similar, I can do this thing too for the current which is flowing downward, right? If this conductor is straight, then the thumb is going to represent the current direction. If the conductor is circular, then the fingers, curl fingers, are going to represent the current direction. Now let's find out what is the direction of this magnetic field when the current is going down, right? So what we can do, thumb represents, right? So this is our conductor. Now where the direction of the current? Downward. So thumb should represent downward direction, right? So like this. So if this is the downward direction, curl fingers are going like this, right? So it is coming from behind and going in front of that, right? So can I say, obviously direction will look something like this now. This is the front side, right? Dotted is the back side, and the direction will be like this, opposite to the first case, we can say. So these are the different cases for the straight conductor as well as the conductor, or we can see in the circular loop, right? Okay. Now let's move to the next part. Now this is the property which we have already seen, right? Here you can see opposite poles attract, and like poles, what they are repelling, right? So like poles means, you can see in the diagram that like poles mean north are there, or south are there. They are repelling each other, and opposite means what? North and south pole are attracting. Now just think on this and tell me the answer. We talked about the maglev train, right? Maglev train means what? Uh, a train is little, we can say it is just floating on that rails, right? So tell me, for that train, which property should we have used? Attracting property or repelling property? Which property? Right? Obviously, right? We have to use repelling property. If we cannot use the attractive property, otherwise that railway will come on the rails, right? That is not our aim, right? It should float. When it will float? When it will repel each other, right? Okay, so this is just one property of, we have already seen this opposite poles. Opposite means unlike poles, we said. Unlike poles attract each other, and like poles repel each other. Okay, so this is just the another property you can say. Now let's talk about this suspended bar magnet, right? Also in property of the magnet, we have seen this part, that if you suspend this magnet, if you punish this magnet, hang this magnet, right? It will show some particular direction, right? So what you can do, just take a magnet. Now remember, we actually don't know, just consider that we don't know which one is the North Pole and which one is the South Pole. What we are going to do, just suspend this magnet like this and just give some push to this magnet. Now, what we can actually observe that this magnet is going to play or get stable or rest at some direction, right? So what we can do, just draw some perpendicular lines on the ground like this, and let's see, okay, I can draw one line like this. Okay, do one more thing, give him push, give the magnet push, let's say from another direction with different forces, right? Then what will happen? Again, let it come at the rest, right? If you observe, when they are going to come at the rest, again you can draw the perpendicular like this and try to join this line. You can see in the second time also the line coincides with the original line, right? Try this experiment again, give the push and find out the when it is going to come at a rest, find out the line on the ground. You can see every time you are going to get the same line, right? So what we can say, that was the property, that is a directional magnet. We can say that if you suspend the magnet, it is going to align itself in the one particular direction only, right? It will never change its direction, right? So why? Because this magnet, we can say, it is going to align itself in the north south direction, north south direction, right? So how to find out which one is the north direction and which one is the south direction, right? We assume that we don't know that this magnet is marked as a north and south pole, right? So what they did, now simple thing, we know that our sun rises at east. So in the morning, do one thing, that go to the east, look at the sun, we can say, right? So we already know if this is the north, this is east, this is our south point, and this is our west point, right? North, east, south, west. So if these are the four different directions, what you are going to do, just face on the face towards the we can say rising sun. Sun means we already know that it is the east direction, right? So observer is like this. So what you can see, the left hand will point here, right? So on this ground, right? Go there, face the east direction, look at the east direction like this. So and stretch your left hand. Left hand is going to show what? North pole, right? So this will be your north pole, and the other will be your south pole, right? So north pole is actually called as north seeking pole, north seeking pole, and the opposite pole is called as south seeking pole. Okay? And that's why we can name them as a north pole as well as south pole, right? So did you understood this experiment, right? If you do have some time, you can try to do that thing, right? What you have to do, take one magnet, suspend it. Suspend means what you can do, just take one stand, tie a string to that magnet, and like that just let it flow like any direction, right? So just give one push, you will get one normal line. When you draw some perpendicular on that, do the same experiment again. Remember that it is going to go into the always going to align itself in the same direction. It is not going to change its direction, right? So this is a simple experiment you can do. And again, I told you how to find the North Pole and South Pole. Right? For North Pole, look at the rising sun. Rising sun means where? When? Is it in morning or evening? Right? Obviously, it is a morning session, we can say. Right? So in the morning, look at the east and stretch your left hand. You will get the north direction. That is called as actually north seeking pole. The other one is the south seeking pole. Okay. Sure. So this is the example or property of the suspended bar magnet. Now, this same property is actually used in compass. Compass means what? right? Compass is the instrument which looks something like this. Now you can see it in the picture. There are two pictures. In the second picture you can see, or let's talk about the first picture. In the first picture there is a one small needle inside, like a pin, right? Very small black colored pin, right? And you can see in the second diagram that that pin is actually rotating. One glass cover is kept on that pin, right? So we can say that pin is pivoted at some fixed point, right? And it is allowed to rotate. Also, let's see on this dial of this compass. You can see this compass. You can see it just look like our normal watch. It also has this nice size of our normal watch dial, right? And on that dial, you can see the N is written there. N means North Pole, right? And obviously there are some angles there, right? And also we already know that um, north, opposite to north there will be south. Here you can, if you max zoom the screen, you can see the south. Similarly here you will see the west, W is written here, east is written, right? So obviously this compass is going to show us some directions, right? Okay, so how they actually show the direction? We already have seen the property of the suspended magnet. What happens when we suspend the magnet? It is going to align itself in north and south direction. N pole means north seeking pole, S pole means south seeking pole, right? So what you can do wherever you want to find the directions, right? In the earlier times, right? Nowadays we even can use our mobiles, right? Mobile phones to find out the direction. Just open the GPS and try driving everywhere, right? You can find out where is the north and where is the south. It's very easier now. But in the previous time, uh, travelers used to have this small instrument which is called as compass, right? On this compass there is a needle like this, and if you want to find out the direction, where is the north, where is the south, what they are, just place this compass, we can say, on horizontal table like this, right? So for example you can also see some maps there, right? Maps are down on this, on which this second compass is kept, right? So you want to, if you want to find where, if you are at some particular point and consider this point some particular place is in which direction, just put the compass there. That needle is going to rotate, right? And needle is going to align itself in the north direction, right? You can see closely here for this compass. I can see some arrow here at one point. Needle is also not equal, we can say similar on the both the sides or both the ends. Here we can see the arrow here. Even in this small needle also, if you observe very carefully, right, there is one dot on this side. On this particular side there is one dot, right? So when this, obviously this needle is not going to flow oscillate like this only. It is going to stop at some particular point, and that particular point is, we can say, we have to, what we have to do, suppose this arrow stops something like this here, right? It moves and stops something like that. Then try to move that compass, rotate that compass such that this arrow is not going to move now. It is going to be stable. Rotate your compass so that N poles comes up to this point, right? So what I can say, this direction is going to show me north direction, right? So this is what most of the travelers used to do. Even in the pirates, you must have heard somewhere, Pirates of Caribbean, right? You must have heard, right? There are, those are smugglers on the ships, right? Or even our normal ships also. They also use this. They used to use this compass, right? Because there is a big ocean, big ocean, and how you can find a direction, right? There is nothing to see on the land. At least we can see something on the land. According to that, we can find out which one is the direction. We can mark the direction. But in ocean, there is nothing, right? So what you have to do, you have to use this compass, and you can easily find out the different directions, right? Okay. Then you can also try one more thing for this compass. If you want to create your own compass, what you can do, take one small needle. Right, in the next session, we are going to also find out how to convert this small needle into our temporary compass or temporary magnet, we can say. Right, if you take this small needle, magnetize it. Right, we will discuss this how to magnetize this, right? And what you are going to do, just find some cork, we can say. Cork means small, we can say, a lead on the bottle, right? Put that needle on the cork such that it is free to rotate, and put the whole cork and the needle is on the top like this. So uh, suppose this is the top view. You understood the top view, right? Top view means if I watch this cork from the top, water is there. We have kept the top cork like this, right? So if this is the cork, let's say our needle will be look something like this. It is kept on this cork. Okay. So this is the needle. So temporarily magnetized. Now we will see how to magnetize that needle, right, in the next session. So if the needle is kept on the cork, in the whole thing, put it in the water, we can say. See, this needle will act as a compass, like this compass, and it is going to show you it is going to align itself into north and south direction. Accordingly, you can find out the north and south. I also told you how to find the north and south direction, right? If it is not marked, right? On compass, we already have some arrow there, right? So arrow is going to tell us which one is north. But this needle, we have to use that method, right? We have to take the help from the sun, right? So this is about the compass, we can see. Okay, now let's move ahead. Just a minute. Okay. So these are the whole theory part of our first session. So what we have studied, let's recap a little bit about that. So at the start, we have seen what are the different types of magnets, and yes, as I said, this is important thing. They could ask you in the exam what are the different types of magnets, right? So very basic, very common magnet is a bar magnet, right? And it is actually not the natural magnet. Natural magnet also we talked about that. Natural magnet is what is natural magnet? Right? That story we heard that about the shepherd called Magnus. He found a natural magnet, right? Lodestone, we can say. Lodestone is also the name of that natural magnet. Then this bar magnet, horseshoe magnet is there, rod magnet, ring is there, then disc is there, and one is our Harry Potter's wand, right? Not Harry Potter's wand, but wand magnet, we can say. So these are the different types of magnets we know. Okay. Then we also seen that what are the magnetic properties. If the fillings are there, fillings means what? Iron fillings, small particles of the iron, and if we use those particles uh, to in the, we can say, in the kept near to the magnet, they will align themselves in particular path. That path we called as magnetic field or magnetic field lines, we can say. So we also know that magnetic field lines have some path, right? Then we also talked about some properties of the magnet. What are the properties? That there are two poles, right? North pole and south pole. Then we also know that like poles what? Like poles means what? Same poles, north poles. Like poles what? They repel each other, right? Simple thing. And what about the unlike poles? Unlike means if you consider north pole and south pole, they are going to attract each other, right? So we have seen those things too. Then we also have seen that we cannot get the monopole. Monopole means what? We cannot find out the north pole. Only north pole is there. Only south pole is there. We cannot find that, right? So magnetic poles do exist in pair only. Pair means what? Both north and south pole will be there. So what happens? Yes, I have to recall that one. What happens if I cut the magnet into, right? If there is south and north pole, if I cut the magnet, what will happen? And I'm going to get the two different poles against how. If you cut the magnet, the if south pole is already there, north pole is going to appear, right, on our path, we can say. Okay, on our magnet, right? So this is how we can get the two poles again, right? But we are never going to get the single monopole, we can say, right? So they do exist in pairs. Right. This we have seen. Then we also have seen the magnetic and non-magnetic materials. Right? Iron material is a magnetic material, I can say. or metals which show some properties, right? Needle is our also magnetic material, we can say, right? Similarly, you can say non-magnetic means which magnet cannot attract. Those are our non-magnetic material, like plastic, paper, clothing, etc. Magnet cannot attract those, right? Then we have also seen uh, freely suspended magnet. What happens if you suspend the magnet? Suspend means just take one rod and tie the magnet to the string. What will happen? That magnet is going to align itself in same position. Doesn't matter how many times you apply the force on the magnet, change the direction of the magnet, it is going to come at rest at the same alignment, same line, you can say. That line is going to show you north and south pole, right? We also know how to find out the north and south using the sun's direction, right? Then, uh, then we talked about the compass. Compass uses the same principle that freely suspended magnets principle, right? It has the freely floating needle, we can say. And who uses this nowadays? We don't need the needle. We have the mobiles, we have the GPS and etc. All those things, so we don't need those. But in the earlier times, travelers were using this thing, right? Okay, so we have seen this part also, how the compass works, what is the needle, how the needle looks like, right? We have seen, even we can see the needle in front of us, right? It also has some north pole sign also there, right? In the first compass, we can see there is arrow. Arrow shows the north pole. In second compass, second diagram, there is some dot on that one part of the needle, which is going to show you the north pole. This is how we can find out the north pole and south pole, right? We also know how to create our own little compass using the needle, cork, and water system. Right? So this is the whole chapter for today. So let's see some questions on this, very simple and theoretical questions. Right? So first question says magnet will attract, right? Which option it could be, whether it is iron piece or pieces of cloth or pencil. We already know that, right? Magnet attracts the magnetic material. We call them as magnetic material, and iron is our magnetic material. So magnet is going to attract iron pieces, right? Very simple. And cloth and pencil, we are going to call those as non-magnetic materials, right? Okay. So next one, the attractive power of bar magnet, right? It must be off here. The attractive power of bar magnet is maximum. Where they are maximum? If you consider this is the bar magnet, let's say yes, poles are there, right and left ends are there, right? If you do remember the iron fillings, right? We have seen one example of the iron fillings are attracted. Maximum iron fillings are at the ends, we can say. Now this will, I think, this is sufficient information for you to answer this question, right? Where is the attractive power maximum? Where, right? At the both end, north and south pole, south end, we can say, right? Or it is equal. It should be actually along the bar magnet. I can say it's equal along the bar magnet. Means this option says that iron filling should also get attracted at the middle portion, but they do, but very less negligible, we can say, right? So maximum strain is at both ends, we can say. Okay, let's move to the next question then. Magnet will always have how many poles? Two poles, right? We have seen that we cannot find a monopole, means we cannot find a single pole. Even if you cut the magnet, the other pole is going to get generated there. So our answer is two poles. Very simple. Right? Then list out the different types of magnets. We have seen these types, right? I say that this question is very important for us. So what are the different magnets? First is a bar magnet, then horseshoe magnet. We have seen the shape of that horseshoe magnet, right? It's U type, we can say. Then there is a rod magnet, a ring, then disc is there, and last one is Harry Potter's, right? Wand magnet, we can say. So these are the different types of magnets, we can say. Simple, right? And what is the unit of magnetic field? Now, this is not a question in which we have studied, but remember the unit for the magnetic field is called as Tesla. Tesla is also one of the scientists, right? Like Newton, then the Einstein also, right? So Tesla is also one of the scientists, and for the unit of the magnetic field, his name is given. Therefore, we can say the unit of magnetic field is Tesla. One another unit is there for this magnetic field, which is called as Gauss. So there are two units there, magnetic field, Tesla and Gauss. Gauss is also, we can say, one of the scientists. He also studied this electric field and magnetic field. Therefore, his name is also given to the unit of the magnetic field, we can say. Okay. So this is all about the magnets, we can say. We have just seen some introductory part. In the next session, we are going to see some more concepts about the magnetism. Also, we will see how the magnetic field works, how the earth. Now remember, the earth is also a very big magnet, very huge magnet, right? Our earth, we know the size of the earth. Earth is spherical, right? Yeah. So earth also acts as a magnet. How it acts as a magnet, we are going to see that part too in our uh, next session, right? Okay. So today we'll stop here. If you do have any questions, please put them on forum, right? And so I can answer those questions. Okay. So we'll stop here today. Thank you very much. Have a nice day.